Hello guys, and welcome to another video. So on this one we'll be looking at how to go about finding the number of moles of our water of crystallization, meaning that we'll be looking for this X basically. Let's get into it. So here they say 4,96 grams of hydrated sodium thiosulfate, which is this substance here, was dehydrated, and formed 3,16 grams of anhydrous salt. Then they say find X. So what we see here is that on this substance we have water. Thus, this is the water of our crystallization. We remove this water, and when it goes, we remain with this salt. So we're trying to find out how many moles of this water is there, or the moles of water of crystallization. How do we do that? Well, the first step is going to be finding the mass of this water. So step number one, find mass of water. Let me just say H2O. How do we find the mass of water? Well, we'll say mass of H2O is equal to what? We will see that if there is water on this substance, the mass is 4,96. So we'll take that 4,96 and subtract our anhydrous. Our anhydrous is this substance here, the Na2S2O3. That is our anhydrous, and its mass is 3,16. So we are going to take that out. When we take that out, we will remain with the mass of water. Okay, so we're taking it from this whole thing here and then subtracting the mass of that particular anhydrous. And the answer we get, I already calculated this, is going to be 1,86 grams. This is going to be the mass of water. The second step is going to be finding the number of moles. Okay, how do we find the number of moles? We find the number of moles by saying N, but in this case, I'm going to find the number of moles of this H2O and also this anhydrous, which is an A2S2O3. But I'll start with water. So I'm going to find the number of moles of water. The number of moles of water I will find by saying N is equal to mass over molar mass. What is the mass of water? It's 1,86. And what is the molar mass of water? The molar mass of water is going to be the number of water atoms, or rather the number of hydrogen atoms, which is 2, multiplied by the molar mass of hydrogen, which is 1, plus, in this case, I have how many oxygen atoms? 1. So it's plus the molar mass of oxygen, and this will give me 18 grams per mole. The answer is already given here. So the molar mass of water is going to be 18 grams. Then when I say 1,86 divided by 18, the answer I get, I already did this, guys. The video just got deleted by mistake. So I'm just gonna write what I got. It's going to be 0,1033. So these are my number of moles. So I can just write mole. Let's write mole, in fact. Yeah. So that's the number of moles of water. Now I'm gonna look for the number of moles of my anhydrous, which is Na2S2O3. How do I do that? Well, I already have my formula, which is mass over molar mass. What is the mass of my anhydrous? It is 3,16. I'm told here that 3,16 of anhydrous salt, and this is my anhydrous. So the mass of it is 3,16. And then I'm going to find the molar mass of that anhydrous. How do I find it? Say Na2S2O3 is equal to, how many sodium atoms do I have? 2 multiplied by the molar mass, which is 23. How many sulfurs? 2 sulfurs multiplied by their molar mass plus how many oxygens? 3 multiplied by the molar mass. How do I know these? The numbers at the bottom represent the number of atoms. So I multiply the number of atoms by the molar mass, okay, to get my molar mass and my total molar mass. So let's quickly do this calculation. So when I add all of these numbers, the answer I get is 158 grams per mole. Once I have this, I'm gonna put it here. That's my molar mass, 158 is equal to, and then from there I'm gonna say 3,16 divided by 158, and the answer I get is 0,02 moles. Okay, once I have this now, guys, I'm gonna move on to my third step. What's going to be my third step? Let me just write it here. My third step will be to find the ratio. So my third step is to find the ratio. How do I find the ratio? I'm gonna take these two number of moles and divide both of them by the smallest number here. Now my question, guys, is between 0,1033 and 0,02. Which number is the smallest? Okay, that's the question I have for you. Please find that out for me. Okay, the smallest number, guys, is going to be this one. How do I know this? What I do is to take this number, subtract it from this, and whichever, or I can take this one, subtract it from that one, whichever way. But whatever answer that gives you a negative value, know that it is the smallest value, okay, when you subtract from it. So here what I said is 0,02 minus this one, and I got a negative answer. Thus I know that this one is the smallest. So I'm gonna divide by this one on both these numbers. I'll say 0, firstly I start with this one that I'm gonna divide with 0,02 divided by itself, because remember I said I'm dividing both of these numbers by the smallest number, which is this one, and then I'll write this as a ratio. 0,02 over 0,02 is to the big number now, which is 0,1033 divided by the small number, which is 0,02, and then from here I'm gonna have my ratio. I obviously know that this one divided by this one is gonna give me 1, so it's 1:2, and then this one here is gonna give me my x. Let's see what it gives. So it's 0,1033 divided by 0,02, and the answer I get is 5,16, but I'm just gonna take the whole number of 5. So my ratio is 1:5. This big number here represents my x. Okay, so I conclude by saying therefore x is equal to 5. And then I'll write this formula with the 5. I'm going to write this whole thing here with the 5. So I'll say therefore Na2S2O3.5 H2O, and that's how I solve this problem. Okay, I hope it makes sense. If you didn't understand, just please scroll back and try to see how we went about this one. The second thing I want us to look at is if they say we have to find, let's say they say find the percentage composition of H2O from here. How would you find that percentage composition? Well, this is how we would do it. Firstly, we would have to find the total molar mass here. Okay, the total molar mass here. But we already know that for Na2S2O3, the molar mass is 158. So I'm just gonna I think I should rub. Okay, let me just put whatever that I want. So I'll say the molar mass of Na2S2O3 5H2O is equal to the molar mass of this one, which is 158, plus the molar mass of this one. But let's notice how many H2O molecules do we have? We have 5. So I'm going to say 5 in brackets 18. So it's 158 plus 5 times 18. Let's see what that gives us. So we'll say 158 plus 5 multiplied by 18. And the answer we get is 248 grams per mole. Once we get this, what we are going to do now is to find the molar mass of H2O. Okay, how do we do that? All right, so guys, we found the molar mass of this whole substance, but I want to rephrase my question. And my question is finding. I want you to find the molar mass, the percentage composition of hydrogen, not H2O. Okay, I made that small mistake there, so please pardon me for that. So I'm just gonna rub here. If you want to see what I've just rubbed, you just go back, rewind. So what I'll do is to start by finding the total molar mass, right? Remember, I'm trying to find the percentage of water. Find percentage of, not water guys, hydrogen. I don't know why I keep on saying water. So the second step now, after finding the total molar mass of this substance of mine, I'm gonna say the percentage of hydrogen on this substance is equal to how many how many hydrogen atoms do I have? I have 2 times 5, so I have 10 in total. So what I'm gonna say is, firstly multiply by this 5. So I'm gonna say 5 in brackets the molar mass of hydrogen, which is 2 times 1. Why am I saying 2 times 1? Because I have 2 hydrogen atoms multiplied by the molar mass of those hydrogens, which is 1, divided by the total molar mass of my substance here. Okay, so here I'm gonna have 248, then I'll multiply all of this by 100. Let's see what I'm going to get. So what I will have is 10 divided by 248. 248 multiplied by 100. And the answer I'm going to get is 4,03%. Yes, that's how you solve this problem. I hope it makes sense, guys, and see you on the next one. Bye bye.